This lesson is on power functions and equations. So the definition of a power function is a function in the form y equals kx to the p. So k and p are constants, and k is the constant of proportionality and p is the exponent. One thing to remember is that they can only be, a power function is just a single term. So you can have a number, and then an x, and then a power, but no other terms. Okay, so here are some examples. So the first one, y equals just x to the 0 power. Well, anything to the 0 power is 1. So it's y equals 1, which is just a horizontal line. That looks like that. The next one, y equals x to the first power, is a linear function. It goes through 0, 0. Looks like that. You don't need to memorize these. This one, y equals x squared, is a parabola. So we talked about this last week. It's going to be a u. And y equals x to the third is a cubic. Looks like that. And then these, we haven't talked about these. You did do them last year a little bit, but x to the negative 1. If there's a negative exponent, then it flips it. So it becomes 1 over x. And that is a rational function. And its graph looks funky. It looks like this. This one is x to the negative 2, which flips it and makes it 1 over x squared. And it has 2 parts as well. But since it's even, they're both on top. All right, x to the 1/2, remember power over root turns it back into the square root. And we talked about this last week. Its graph looks like this. And the last one, the cube root, remember it's like a cubic that's been twisted. Looks like that. All right, this next part is what's important. This is what's going to be on your test, this section. Determine which are power functions. Circle yes or no. If yes, state the value of k and p. Okay, so this first one. You do need to do power over root to give it an exponent. So it's going to be x to the 12 over 3, and the 5 drops down. Well, 12 divided by 3 is 4, so that's simply 5x to the 4th. All right, if you have a number and then an x and then an exponent, that makes it a power function. So this one is a yes. K is the number in front. It's your coefficient, so that's 5. And p is your power, which is 4 in this case. All right, this next one, remember the square would mean to write it twice, and then you would have to lobster claw it. Well, this is not going to be a power function because you're going to have more than one term. It's going to be a polynomial. Power functions are just single terms. So it's not a power function because you're going to have more than one term after you lobster claw it. All right, this next one is very tricky. Okay, so the square root of 36 is 6. And what you want to do with the x is write it power over root, so 5 over 2. But what makes it tricky is that since x was on the bottom, the exponent is a negative. So this is a power function because you have a number and then x and then a power. So k is 6 and p is negative 5 over 2. Okay. All right, on this next example, you need to get y by itself. Okay, you need to get y alone. So you're going to minus 2. Well, that cancels all of those out. And then divide by 10. So you get y equals 1/2 x to the 4th. Okay, that is a power function. And k is 1/2 and p is 4. Okay. All right, this next one, is it a power function? The answer is no, because x is in the exponent. So for a power function, it has to be a number, and then x, and then a number up high. So if x is in the exponent, that makes it an automatic no every time. All right, this next one, you have to be careful. When you lobster claw, you get x squared plus 3x minus 3x minus 9 plus 9. So a lot of your terms cancel out. Those cancel and those cancel. And to get y by itself, you need to get rid of 1/4, so you can multiply by 4. So you end up with y equals 4x squared. So that is a power function. K is 4 and P is 2. All right, so let's work the last one out. Distribute your 3x plus 3. Get y by itself, subtract 3. So you're left with y equals 3x. So that's, yes, it's a power function. K is 3, and your power is 1. All right, remember, you can pause if you need more time to write this down, or you can rewind it. Okay, we're skipping the next part of your notes, and we're going to the part that says direct and inverse variation. So the direct variation equation is y equals kx, and the inverse variation equation is y equals k over x. Okay. And don't worry about that. All right, so let's read this. Suppose y is directly proportional to x. If y equals 18 when x equals 8, find the constant of proportionality k. After finding the formula for y, then use it to find x when y equals 27. Okay, so your keywords is directly proportional, which means you're going to use the formula y equals kx. All right, start at the beginning. Y equals 18, so I'm going to plug that in for y. When x equals 8, so I put k times 8. And it says find what k is. All right, so to do that, you just divide by 8. And you get k to be 2.25. Well, you're not done. Now you need to use the formula to find x when y equals 27. So I'm using the same formula. This time y is 27, and I now know what k is. K is 2.25, and I'm trying to find x. To get x by itself, you divide by 2.25, and you get x to be 12. All right, B. Suppose C is inversely proportional to the square of D. If C equals 4 when D equals 2, find the constant of proportionality, K. After finding the formula for C, then use it to find C when D equals -8. So the keyword is inversely proportional. So you're using y equals K over X. However, this time they've got different letters. So let's make y be C. K stays the same. And let's let D be X. And there's one other trick on this one. It says the square of D. So we need to put D squared. So this is the formula we're going to work off of. If C equals 4 and D is 2, find K. So 4 goes in for C and 2 goes in for D. And we're going to get K by itself. So we need to multiply by 2 squared. So we get K to be 16. Okay. After finding the formula, then use it to find C when D is -8. So we're going to use the same formula. This time, find C. So C equals, we know what K is 16, and D is -8, and you have to square that one. So you get 0.25, or you could do 1/4. Either one is correct. All right, last example. The radius of a sphere is directly proportional to the cube root of its volume. If the sphere of a radius is 18.2 centimeters, if a sphere of radius 18.2 centimeters has a volume of 25,252.4 centimeters squared, what is the volume of the sphere if the radius is 19.3? So keyword is directly proportional. So in direct variation, it means you multiply your constant with your variable. In inverse, you divide them. So direct means to multiply. So let's set this up. The radius is going to be r. Directly proportional means I put a k times the cube root of its volume. So the sphere of the radius is 18.2, so it goes in for r, equals k, and the volume is 25,252.4. All right, to get k by itself, you just divide by the cube root of 25,252.4, and you get k to be 0.62. All right, the question says, what is the volume of the sphere if the radius is 19.3? So we're going to plug back into this formula. This time the radius is 19.3 equals, we know k, 0.62, and the cube root of v. We're trying to find the volume. So to get v by itself, first thing you do is divide by 0.62, and that gives you 31.129. And then to get rid of the cube root, you raise it to the power of 3, which gives you 30,164.55. And that's your answer.